video, we will explain some methodologies of preparing solutions and also some advices that should be taken into account in order to verify that a solution has been well prepared, such as the following. Before preparing any solution, it is important to know the reactives that you are going to work with. Know the desired volume. It is important to know the protocols of each solution, the solution quantity for each reaction, and the volume unit. Adjust pH. Some reactives need to adjust its pH, and it is important to check in literature the solution it needs to be adjusted with. And if a solution was not prepared correctly and the concentration is not adequate, there could be consequences such as the pH will change and affect the solution could be oversaturated if the concentration of any of the components is higher than it was supposed to be, and taking Le Chatelier's law, we can assume that the direction of the reaction could change.
The general steps for a proper solution are the following. Select the reactive solute to use. Perform calculus for the preparation of solutions. Choose the right material where the solution is placed. Despite the solute in analytical balance. Dissolve the solute. Prepare the final volume in the chosen instrument.
It is important to read the label reactive because you have to take into account the specifications if once prepared the solution needs special handling or storage.
Also, we want to talk about sterilization types. We are going to focus in 4. The stem sterilization, that it works to sterilize materials tolerating high temperatures. It's fast and easy to control. 2. The ethylene oxide sterilization. When mixed with an inert gas, it produces effective sterilization by destruction of DNA and protein structure of microorganisms. 3. Ionizing radiation sterilization. They are used in the medical supply industry. They are characterized by high energy and high penetration. 4. Chemical solutions. Cold sterilization, consisting instrumental immersion in high-level disinfectants and allow the sterilization of thermosensitive materials.
Our team was requested to prepare 4 different solutions, which are the following ones.
The total amounts weighted for each solution were 0.7768 grams of calcium chloride for this solution. In the case of the phenyl chloroform solution in a 25-24:1 proportion, 17.5 milliliters of phenyl were required, 16.8 milliliters of chloroform, and 0.7 milliliters of isoamylic acid. In the case of hydrochloric acid, 5 molar, after mass calculations, we decided that 12.35 milliliters were used, and the rest will be added of water. And finally, for the 200 milliliters of TBE, 4.464 milliliters of EDTA were used with 11.1295 grams of boric acid and 24.4 grams of tris base.
It is of extreme importance to understand the different types of concentration parameters that can be used while preparing solutions.
Some of these parameters are molarity, that is used when dissolving a solid into a liquid or dissolving two liquids in each other; normality, that is used when preparing acid or basic solutions that are pH specific; parts per million, that is used when the solute is in very small quantities; and percentile, that is used when the final product is mass specific. Some of the things that should be taken into account when preparing the solutions are: not all the glassware is precise, so the use of a volumetric flask is important to achieve an optimal concentration. If the reactants are old or mis-stored, they won't be as pure as expected. The order of the solute addition in pH-specific solutions is important. When working with solutions that are acid or basic, the following should be taken into account: use of gloves, fume hood, and clean glassware. Some reactants are thermosensitive, some reactants are photosensitive. The glassware will not always be properly cleaned and stored, so it should be washed before use. When the solutions are pH specific, there should be constant stirring to have a homogeneous solution. The stirring magnet size depends on the glassware being used. Correct labeling of the solution should be done to avoid mishandling.
And finally, our team's conclusion is the following.
A proper preparation of solution will be feasible if both theoretical and practical phases are performed correctly. It is also important to know the nature of the solutions that are being prepared so the right precautions are taken not only for the preparation but for the disposal too. These precautions should be reported in literature and will increase the quality of the solution.